So now what we want to do is find an equation of a plane, right? So remember, think about how we constructed the plane. We again need two pieces of information. One thing is a point on the plane, and another thing is a vector which is perpendicular or normal to the plane. Okay, so here we have an example, and we want a plane that passes through 3 given points. So that more than takes care of the first criteria of having a point on the plane. However, now we need to find a vector which is perpendicular to the plane, or normal to it. So how do we go about doing that? Well, so let's choose first our point that's on the plane, the one we're going to use in the equation. And, well, since it's first in the list, let's take P. So we'll say P is sort of let's call it a base point. Right? So this is where we're going to kind of build the plane from. Right? So we can get two vectors in the plane by doing the direction vectors PQ and PR. So two vectors in the plane. We have PQ, right? And remember, this is just going to be tip minus tail. So Q is the tip, P is the tail. So tip minus tail here will give us 1 minus 0, 0 minus 1, and 1 minus 1. Right? So 1, negative 1, and 0. All right? Now we're going to construct another vector starting at P and this time ending at R. So PR. And again, it's tip minus tail. So 1 minus 0, 1 minus 1, and 0 minus 1. Okay. So now we have two vectors that are in the plane. But we really want a vector that's perpendicular to the plane. Do you remember how to take two vectors and create one that's perpendicular to both of them? So let's think about that for a second. Okay. Well, hopefully you remembered that the cross product of two vectors is perpendicular to the original two. So, to get a normal vector, we take the cross product. Right. So we're going to call it N for normal. Right. And this will be PQ cross product PR. And now we just have to compute that. So we have our determinant I, 1, 1, J, minus 1, 0, K, 0, minus 1. So if you remember, the first row has I, J, K. The second row is the first vector. The third row is the second vector. Do remember that the order of these rows is very important. You might remember that A cross B is negative B cross A. Okay, so let's actually compute this cross product now. Well, to get the first one, we're going to crush this first column and the first row. And then we have minus 1 times minus 1, which is 1. And then we have minus 0 times 0. So just 0. Right? For the second entry, remember there's a minus sign here now around the whole thing. And we're going to crush the first row and the second column now and do that same little 2 by 2 determinant. So this time it's 1 times minus 1. And then minus 0 times 1. So minus 0. Right? And lastly, the third column, well, there's no special minus sign anymore. We're going to crush the first row and the third column and do the determinant of this little 2 by 2 here. So we have 1 times 0, which is 0, minus negative 1 times 1. So we're subtracting negative 1. Right? And if we simplify all this, we'll see the vector 1, 1, 1. Right? So that's our normal vector. And now we just have to combine this with the equation we had before. So that was n equals, or sorry, n dot product x, y, z minus some point p on the line, right? So this was the direction vector from what before we called q and p. Right? So that looks like 1, 1, 1. This was the x minus x naught, y minus y naught, z minus z naught. So x minus x naught is 0 here. Y minus y naught, well, y minus 1. And same thing for z, z minus 1. Right? And then that had to be 0. Right? So that said the normal vector to the plane, 1, 1, 1, is perpendicular to any vector in the plane, which is given here. Right? So if we write out this dot product, we get x plus y minus 1 plus z minus 1 is 0. And we can move things around and get that that's the same as x plus y plus z equals 2. Right? So it's really okay to sort of stop here. This is the vector equation of a line. Or, sorry, not of a line. It's the vector equation of a plane. Or we can multiply this dot product out. We could stop here if you want. Or this looks a lot nicer. We can stop there, which is sort of the most compact form of the equation of a plane.